Good afternoon, everyone. This is Robert Haynes with the National Weather Service in Burlington. We will now get started on our presentation. Welcome to our Skywarn Spotter training here, and thanks for joining in this afternoon. We'll talk a little bit about understanding flooding and the National Weather Service flood products. We wanted to present this information because flooding is one of the primary impacts that the North Country faces whenever it comes to severe weather. I have Andrea with me this afternoon, and we are going to co-host this. Andrea works with the hydro team, and she'll help me out with her expertise as we go through this presentation. You'll see whenever we go through the presentation that there are numbers on the top right. That way, if you have any questions about a particular slide, you can write down which slide number you have a question on. We can easily hop back to it. We also have a little bar for questions. You can type in your questions and we'll have one of us checking up on that to help answer some of the questions you might have. And we'll also make sure to have any periodic breaks so that you can ask your questions then as well. Before we begin, are there any questions before we get started? All right, nothing heard. We will begin then. All right, so here's what we'll be discussing today. We'll talk a little bit about why floods occur. We'll talk about the river basins that make up for it, having a good understanding of what a river basin is. We'll tell you a lot about what kind of flooding will occur in it. With that, we'll also talk a little bit about the different types of flooding. There's flash flooding and then there's regular flooding. One is more gradual, one happens more quickly and results in very fast stream flows in rivers. We'll talk about when flooding is most common in the North Country and when those impacts are most likely. We'll talk a little bit about the River Forecast Center. They are the experts when it comes to river forecasting. They know quite a good deal about how rivers function, the areas that are involved, and the impacts that can occur from floods. We'll talk a little bit about what they do and the forecasts they produce that help us in issuing flood products. And then from there, we'll talk about how we observe and issue some of those flood products. And then we'll discuss a little bit about some of the information that spotters can provide that's valuable to us whenever we are looking at the potential for flooding. Before we get started, I do want to mention safety. The force of flooding is something that's often underestimated. Across 2018 and many of the multi-year averages, flooding is the #2 cause of weather-related fatalities. It's certainly something that's a little more dangerous. It's sometimes hard to see what exactly is happening underneath any flowing water, and that makes it one of the more dangerous hazards. Something not to underestimate. The power of running water is something like if there only takes about 6 inches to knock over an adult, as much as a foot can carry away a car, and then 18 to 24 inches can even take away some of those larger SUVs. Especially if it's at night, you can't necessarily see the floodwaters perhaps, and you can definitely not see the bottom of those floodwaters. If at night, if you do see any road signs, make sure to always obey any traffic signs that you see or any barricades, and always make sure to turn around. Don't drown. It's nearly 2/3 of the statistic that for people that drive into floodwaters, nearly 2/3 of the deaths are related to people driving into floodwaters. So never ever take that risk to drive into floodwaters. Or you could end up like this with a relatively new car here. You could end up in a washed out roadway and in a little peril. In the event of high waters, always seek higher ground. Sometimes that may mean you have to leave your interior structure. Use your best judgment in any of these scenarios. It might be that there's still severe weather happening outside. Just do your best to remain calm and stay away from floodwaters. And so with this, we will now go into some of the science of flooding and why it takes place. Like any good engineering system, or if we have any engineers on the line, it's all about balances here. What exactly is going into the system and what all is coming out of the system. Throughout elementary school, we always talk about the water cycle, and that is the guiding principle for whether or not we have a river in balance or a river out of balance. There's several factors that affect how easily water comes into a system like a river and how quickly it goes out of that. We typically group these areas of common characteristics together into watersheds or basins. Whenever a flood occurs, we then consider how much water is going into that watershed or basin and how much is going out. If things are gradually increasing, that's going to be something that's a flood, whereas a rapid contribution into these rivers is going to create something like a flash flood. I have a little schematic on the right to kind of illustrate some of that. You can have a river and you have tributaries, snowmelt and rain that can contribute, and then going out of the river, any infiltration into the nearby soils around it, as well as the natural stream flow of that river and evaporation will take water out of the system. But if it happens to be that your tributaries, rain and snowmelt, are all putting in water much faster into that river than any infiltration, stream flow, or evaporation can take out, then that's when you're going to start seeing your river rises. And hopefully it's something that's not too quick. So now we'll have Andrea discuss a little bit about the hydrologic cycle here.
Hello, everyone. So as Robert kind of already alluded to, the hydrologic cycle or the water cycle is imperative to understand the transfer of water throughout the Earth atmosphere system. And so there are some primary components that make up the water cycle. We have evaporation, transpiration, and condensation. So water from the oceans evaporates and condenses to form clouds, as well as transpiration from forest systems, grass, surfaces that can transpire water into the atmosphere. And then these clouds produce precipitation, such as snowfall or rainfall. And then these sources of water run off into our streams, into our rivers, and produce runoff, which then infiltrates into the ground. And this cycle is a continuous cycle. So once the water reaches its final stage, it then runs off back into our main sources of water, the oceans, and then the cycle repeats itself. So what is a river basin? A river basin is a drainage basin of any area of land where water collects and then drains off into a common outlet. In the Northeast, we have three primary national or U.S. river basins. You can see those highlighted in the graphic on the right. For most of New England and the North Country, outside of the St. Lawrence River, we are bound by the Mid-Atlantic Basin and the New England Basin. Within these river basins, we can subdivide those into smaller river basins. For instance, the Winooski River Basin, the Missisquoi River Basin, and so forth. And then those can also be subdivided into even smaller watersheds that are made up of tributaries and creeks and smaller sources of water that all feed into these larger river basins. The size of these river basins and the topography of these river basins have a great influence on the flood potential in a specific area. The smaller basins tend to be more prone to flash flooding as the water that falls into them, the threshold for it is much less than a greater river basin, for instance, like the Mississippi River Basin. So how does water flow? Water takes the path of least resistance. So it's going to try and flow at the best of its ability. In order to understand the type of flooding that may occur in your region, it's important to understand several factors, including topography, soil composition, and whether or not you live in an urban versus rural area. This all contributes to what is known as runoff. And runoff can be defined by three different factors. Overland flow, such as the water that already exists on the surface plane, so rivers, creeks, Lake Champlain, things of that nature. Then you have inner flow, such as the water that's moving below the ground, so the water that moves within the what is the word I'm looking for? Like the well water that you're trying, like groundwater sources. And then three, we have the precipitation that falls directly over an area, and that water also contributes to runoff. And so obviously living in the North Country, we live in a highly terrain-driven area. So the role of topography is very important. We have an example here of Chelsea, Vermont. You can see in this graphic on the right-hand side that Chelsea, Vermont is situated within a valley, and all around it you have the high terrain and the slopes. And in these areas you have snowfall that gathers in the winter, and that produces runoff, as well as during flash flooding or during summertime thunderstorms. This can cause flash flooding because all this water typically, if you look and can see my mouse, you have these eastern sides of the ridge here, and that water will flow into Chelsea to the easterly direction. And then you have the ridge on the south side, the east side, and the northeast side, and all the runoff that is produced on these western slopes also will fall into Chelsea. And then it's kind of difficult to see, but this water will flow northward. And so you have a large contribution of different areas of runoff that can contribute to flooding potential. And Terry, we saw that you rose your hand. I am going to unmute you if you wanted to go ahead and ask your question.
Yeah, the mountains, are those the mountains where the whales were actually found? They found whale bones I saw over at the Echo Museum. Is that in Chelsea?
You know, unfortunately, I do not know the answer to you for that, but that's something that after we finish up this webinar, we can definitely do some more digging and find out for you.
Thank you.
Sure. All right, so moving along, something that also, in addition to the topography of the region, that makes up a large contribution or a consideration for the type of flooding that you may get in your area is the type of soil composition. So there are certain surfaces that are more permeable than others or allow water to be able to sort of easily soak into that, where other surfaces are impermeable that have little space for water to infiltrate. And this will contribute to greater runoff in these areas. So much of the North Country typically resides, if you look at the graphic on the right-hand side, more in this left-hand corner. A lot of sandy loam, loamy sand, sandy clay loam type of soils. And so most of the area has fairly well-drained soil. There are a few exceptions though. The one most notable would be portions of Addison County, which actually have a large soil composition up in this more like top right-hand corner of the diagram with more clay-like soils. And so there's actually portions of Addison County, for one, it makes great farming soil, but it also contributes to a higher likelihood of flooding in these areas because clay is a fairly impermeable surface. I'm sure if you guys over the last several years have heard about some of the very devastating flooding that has happened down in Texas, most of the areas in Southeast Texas have very clay-like soils. And so when you get 8 inches of rain in a period of time, that water doesn't have anywhere to infiltrate into the soil. And so it all just becomes runoff. And so the other thing as well as we're speaking about impermeable surfaces, the role of urbanization plays a large factor as well. Concrete is a highly impermeable surface. So practically all the water that falls onto this surface is straightly converted into runoff. In addition, the types of surfaces, the path of the roads can make a difference as well. Meandering roads or straight roads will affect the time that it takes for this water to cover similar distances. And you can see here on the graphic on the right, this is a picture of flooding that happened in 2012 from a pretty prolific thunderstorm in Burlington. They received about, I believe it was about 2 inches or so within an hour. And so this is right around the UVM campus, and you can clearly tell there are cars submerged underwater. There's videos of people swimming, taking canoes and kayaks down the street. And so in these urban areas, they require less rainfall over a given period of time to cause flooding rather than in a rural area. So we have a fairly good rule of thumb here that you can expect some type of urban flooding to occur if you receive 1.5 inches in an hour or 1 inch in an hour of rainfall. So, that's why we typically in these urban areas see pretty prolific flooding in the summertime because of these heavy precipitation thunderstorms. And Burlington's not the only place in the North Country that can have this sort of urbanized flooding. Rutland and Barre as well tend to see this. And I will just put a little plug at the bottom there. If you're interested in learning more about urbanization, there is a paper that was done by one of the forecasters here in the office, along with several individuals from UVM that basically talk about improving the detection of flash flooding in these urbanized areas in Vermont.
And with Andrea mentioning that study, if you do look at the handout tab, you'll see that there is this presentation. You can have this in PDF format, so you can review this later. Before we start talking about flooding versus flash flooding, are there any questions that you have at this time?
And if you can't figure out how to unmute your mic, if you raise your hand, we can unmute you as well from this end, or feel free to type something into the little chat box.
All right, no questions heard at this time, so we'll start talking about some of the differences between flooding versus flash flooding. The key difference is how quickly is your water rising. A flash flood is going to occur from rapid contributions into a river, whereas a flood is going to be caused by several factors that gradually cause your rivers to overflow their banks. We have two examples in video form here for you. On the bottom left is an example from Ellicott City, Maryland, where torrential rainfall caused water to make rivers out of the streets in the city there. Oops, we'll see if we can't get that loaded here. Oh. Well, let's at least go towards a flood example. On the right, we have a video from Vermont Agency of Transportation, where it has a view of the White River by Stockbridge, and you can see the water overflowing its banks. Several contributing factors include some of the snow melt that you can see occurring. There's some fog occurring over the snow due to some of the warmer air temperatures helping that to melt. And then we also had several inches of precipitation that helped to contribute to these river rises that caused flooding. This was April 15th and 16th in 2019. So a flash flood is going to be caused generally by excessive rainfall falling in that short window of time. That 1 inch an hour rainfall rate is going to be something that will especially cause flash flooding in urban environments. In the instance that water is not able to effectively leave any of the systems that it's going into, it can then transition into an aerial flood or river flood if water is allowed to maintain or remain in place. Flash flooding by county, in general, where the areas that are going to be most prone to flash flooding are going to be from any areas that are slightly urbanized or any areas that have a lot of terrain, like Essex County, New York. That area is going to be prone to flash flooding just due to how steep some of the hills are off of the Adirondacks. You'll see in general that Grand Isle is the least flash flood prone. Less development and general proximity to Lake Champlain is going to keep them out of any flash flood concern for the most part. Looking at this example here, we had a pretty good storm that came through, the Halloween storm from last year. This produced very heavy rainfall in a short window of time. This was caused by a strong area of low pressure that set up across the Great Lakes. Whenever this happens, if we get an efficient stream of moisture that's coming from the Gulf of Mexico, and if you have good upper level support like this system had, also in this instance, the area of low pressure was slow moving. All of these factors can combine together to result in several rounds of heavy rain. During this event, we had record crests at the Missisquoi at North Troy, as well as in Lamoille at the Lamoille River at Jeffersonville. This is a good example of flash flooding where you have a stretch of 2 to 4 inch rainfall totals all across the central Champlain Valley. And here's just a quick radar loop just to show all of the several rounds of precipitation that occurred starting in the afternoon and continued in the evening and even into the overnight hours. Rainfall continued to fall. And so as a result, you had quite a bit of flooding.
So in addition to flash flooding, we also have to worry about Lake Champlain. And so there are a combination of factors. I'm sure some of you all remember, if you've lived here for a while, for the record lake levels that we had in 2011 on Lake Champlain. There were a few primary reasons for that. The first was that there weren't a lot of leaves out on the trees yet. So they were not taking up as much water as they otherwise would have been if this was more in the summertime. We also had record late season snowfall in addition to record spring rainfall. And so the next image that I'll pop up here kind of shows the hydrograph that was at Lake Champlain. This was in Burlington, Vermont. And so you can see that we have our flood stage defined at 100 feet. That's this red and white sort of dashed bar in the middle. And that the lake was already slowly sort of creeping up. And then when we had this late season, spring rainfall, you can see this jump up of the hydrograph here, the lake level. And so it actually went into flood sometime in mid-April, and then it reached its peak stage at 103.25 feet on May 6, 2011, and it actually remained in flood stage for over, I believe, 40 days or so, and it didn't finally drop below flood stage until mid-June. And so if you hear this, our next graphic, this is an image of some shoreline houses that were inundated with floodwaters because of Lake Champlain. And this is one of many images that were received across the area. You know, there were roads that were impassable, Route 2 going into the islands. People had to go up to take the northern route, you know, coming into St. Albans to get back over into Vermont. And it was just catastrophic flooding. Now, granted, we don't typically see this magnitude of flooding on Lake Champlain really all that often. I believe it was last year or the year before that that we did reach flood stage, but that the impacts from that are much less than when it was at 103 feet. Typically, water might lap up onto roads that are very close to the shoreline and things like that. But one of the other contributing factors that we worry about with Lake Champlain is wind direction. Since it is a large body of water and it's north-south oriented, depending upon which way the winds blow across the fetch of the lake or the length of the lake, you can have different types of flood impacts, where if we have a south wind that's howling over a long period of time, the impacts will typically be felt more on the Canadian side of Lake Champlain and along the Richelieu River where it drains. Or for instance, on the south side, if we have northerly winds, where maybe areas near Ticonderoga might see some water lapping over instead. And so in addition to flash flooding and lake flooding and just various types of flooding, we also have to worry about flooding due to ice jams in the winter. There are several different ways that ice can break up in the river time, and there's certainly different factors that contribute to ice development in the winter. You know, the length of the winter, how cold it's been, can determine as well both the aerial coverage and the thickness of the ice. And so there are two ways that we can lose ice in the springtime. The good way that we want to lose ice is thermally via melt out. This is what we saw this year. We did not have any real ice jam problems other than a couple isolated ones kind of along the northern channels in Vermont, and then there was one out near Messina in New York. But otherwise, it was a really fairly mild ice out year for us on the rivers. And typically what you want to have this melt out is just mild sunny days, long duration, gradual warmth, not a lot of rainfall, the ice just kind of corrodes over time. And you can see that in the picture. You know, you're starting to get kind of darker colored ice. Water might be able to flow over top of it. There's open channels within there. And so this is what, in a good year, we want to see for ice out. Now, the contrary to that is something called mechanical or breakup of ice. And this typically happens when there is a large influx into the river from either rainfall and or snow melt. You can see that the thickness of the ice is also really important. This picture on the right-hand side was from an ice jam that happened in 2018 along the East Branch of the Ausable, where we ended up with, I believe, 3 inches of rainfall and snow melt combined that all fell into the high peaks down into the Ausable River. And then the thickness of the ice was about, I believe, 12 to 18 inches. And so generally, to have this kind of river breakup that you see, ice breakup that you see, you need the river to rise 3 times what the ice thickness is. And so in this instance, the river rose at least 3 feet from its first stage with all of this contributing water into the river. And so then we get these ice jams that form where ice will typically hold itself on the bottom of the river. And then as this ice starts to move over top of it, it jams and it kind of remains in place. That typically happens at very specific areas on a river, and it always more than often happens in the same locations continuously. And that really has a lot to do with 2 different things. One, it has to do with the change in the channel. So how the river bends, whether or not it gets bigger or it narrows, or the gradient of the slope of the river lessens. And then as well as bridges or piers that might impede the flow of the river as well. And so the next slide will show where we typically see these ice jams. And so here in Vermont, they're very common along the Winooski River. You know, Montpelier, there was the historic ice jam in 1992. They happen in Waterbury. And then we also have them, you know, the Winooski at Essex Junction, and then the Missisquoi as well with Swanton, North Troy. They tend to see them quite a bit, and then as well as the Passumpsic. But you can see by the red dots on the image on the left that almost every single river that gets ice on it in the wintertime has the potential for some type of ice jam to occur. And if you look at the graphic on the right-hand side, you can see that most of these tend to happen in the springtime. The majority of them happen in March, but we do get them in January and February, which are likely attributed to the sort of January thaw that we get every once in a while in the winter. And so here are a few images that you can see. The top left one is Williston Road with the Winooski at Essex Junction sort of flowing over it. And you can see those big ice flows coming up onto the road. The bottom left is Swanton ice jam flooding from January 2018. And this was a particularly difficult event because not only did we have flooding that occurred from the ice jam, but then just in the wake of it, we ended up with like incredibly cold Arctic air mass in place. And so all this water that flooded into these areas all froze in place. And so that added additional complications to sort of mitigate that ice jam removal. And then here's a pretty old picture. I believe this is from I think 1992, 1998, of flooding along Route 78 in East Highgate. But you can see how large these chunks of ice can be, that really it's impressive that the force of this water can move them the way that it does. And just as a sort of safety note, if you ever see an ice jam, sort of remove yourself from them, get a safe distance before you report it to us, because they're highly unstable. You don't ever know when the river is gonna finally release that jam. And when that happens, you can have just like this large flood wave that sort of propagates down the river. Those ice flows sort of back up onto the roads and in places. So they can be highly dangerous if you're in close proximity to them.
All right, thanks, Andrea. So we've discussed a little bit about flash flooding. looked at Lake Champlain flooding and ice jams. Are there any questions at this time? All right, so let's discuss then when flooding is most common in the North Country. Generally, flooding can occur at any point in the year, but there are a few set of seasons that are particularly more prone to flooding than others. In spring, you have the contribution of snow melt that will saturate soils. What ends up happening is you have soils that are saturated, and as a result, water can't really penetrate into the ground, and it could also still be frozen at that point. So as a result, you have more efficient contributions from runoff into rivers and tributaries that can cause fairly quick rises in water levels. This can produce things like ice jams, where you can get ice to cover roads, and as a result of any frozen ground that still hasn't thawed or those saturated soils, water is going to be difficult to move out of that area as well. So spring is going to be some of the more impactful flooding that we get in our area. Once you get into the fall season, your vegetation is going into dormancy at that point. And so as a result, any of your trees, hedges, or any other plant vegetation is not going to collect as much water, and so you're going to get more runoff. Also in the fall, you're going to start getting more dynamic atmospheric patterns that bring up strong moisture-laden storms into our area. This can be from any non-tropical cyclone, as occurred in October of 2017, or the 1927 flood, or in the case of the Halloween storm that we've already brought up. That can be a case where you get flooding in the fall. Other good examples are from recurring tropical cyclones like Floyd and Irene. Those are kind of the flood impacts that we look for when we get into the fall season. During the summer, while river flooding is less of a concern during the summertime, we do look out for flash floods. Thanks to the summertime daytime heating, thunderstorms can quickly develop, and due to the summertime, in the summertime, the flow aloft is going to be weaker. And so as a result, sometimes these thunderstorms can stay in place or even train over an area for multiple rounds of rain. This can cause localized flash flooding that may not impact a wide area, but that local area that is experiencing some of that flooding could experience more than just what a river flood might do to them. So these are when flash floods are most common. Will be June, July, and then it'll start to taper off into August as we start to lose some of that daytime heating that provides the energy for these thunderstorms to develop. And then again, you'll see a little bit of a tail towards March and November as you get some of those strong late season or early season systems that kind of bookend the warm season. So having looked at that, let's talk a little bit about the River Forecast Center and what they do. The River Forecast Center is dedicated to looking up any information related to rivers to provide water forecasts and information. They primarily do that for us here at the National Weather Service, but they also have customers for dams and other kinds of hydro-related civil engineering type stuff that helps to pull in all of that information and model any water that's going to be moving across streams and rivers. And then they also provide climate information to provide kind of indications on what standard stream flows are like. For our area, the Northeast River Forecast Center serves us. They are in Norton, Massachusetts. We have their vision statement, keeping a watch over our nation's waterways. And so what that is making sure that they can minimize loss to life and property from the damage of flooding through their accurate forecasts. We rely on them a great deal as they are experts on our area for what river flooding looks like. We rely on that. They provide all of the forecasts for our rivers. We use that as a tool when we start messaging for potential flood concerns in our area. So let's look a little bit about how the RFC crafts their river forecast. They take a look at observations in precipitation trends. They go through each morning and quality check all of these different co-op, Cocoa Raws, or any mesonet site that kind of provides information. With our radars, we can also produce algorithms that can estimate precipitation rates in a certain area. And with that, they can then assimilate all that data in to ascertain stream level discharge and water levels for the next 72 hours. They take the rainfall forecasts they do their own rainfall forecast, and then they also input our information into various streamflow models. They have several different options to kind of help. Depending on what the situation is, they can apply each of these different models to forecast the stream flows. A few examples I have here, like the Sacramento model. This was created as a result of some flooding out in the western US. It's something that kind of takes into consideration it's dependent on current stream flow observations, whereas something like a hydrophobic model is independent of stream flow observations, and that's going to basically assume that no water is going to go into the surface and that all water is going to be runoff. So something like a hydrophobic model is going to create a very quick reaction. So what that would look like in a hydrograph would be at the end of the line, the purple line would indicate where your forecast is, would be a much sharper rise than any other stream flow model that would be available. Other models, the most commonly used is the CREST model. That one is dependent on current stream flows and takes into account current inflow and outflow of water, as well as what precipitation will be going into the system. We can also fine-tune things. Ensemble forecasting systems have revolutionized the way we do forecasts at the Weather Service, and the same can be said for the River Forecast Center, starting to implement things like the MMEFS or the Hydrologic Ensemble Forecast System as well. What that does is it can give us actual probabilistic information that can actually say, hey, there's a 10% chance or a 25% chance of flooding in a certain area. What really is most useful about this is it can give us the most likely range of possible flooding, and they can fine-tune the hydrograph based on whatever the ensemble forecast indicates is the most likely solution. And that can provide something that is valuable where, as opposed to a deterministic system like the three streamflow models I mentioned before. All of those things go together in forecasting the hydrograph, and it's a valuable contribution for us. Looking outside of rivers, you have flash flood guidance. The River Forecast Center also takes into account previous rainfall. They also look at soil saturations. One of the neat and useful technologies in our satellites is that they can provide remote sensing. They can tell us information about how saturated soils are without having someone actually on the ground to observe how moist a soil is. They can then take this information and apply any terrain features or soil composition data, and they can then go in and create these three segments for flash flood guidance. We've already alluded to the idea of 1 inch per hour rainfall rates already being a good proxy for whether or not flooding can occur. These maps help us to take things like terrain features into account when we're forecasting precipitation rates. They give us good guidance as to how much rainfall is needed to cause flash flooding. So when we're generating our rainfall forecast for the area, especially in the summertime, we keep these maps in the back of our head. They're a tool that we will reference when we look at our precipitation forecasts to determine whether or not there is the threat for any flash flooding in the area.
And so kind of piggybacking off of what the River Forecast Center does, these hydrographs that you can see here on the right-hand side, we use these as well to monitor river levels They are from a river gauge that reports these to us at at sort of regular intervals. Although they come in about once an hour, but each point is representative of every 15 minutes a stage on the river. And these are utilized not only for us to see what the potential forecast is, but the blue line on the left-hand side of the graph is the observed river stage. And so we use those in order to issue some of our river flood products. So if we see that a river is going into minor flood stage, or we see a rapid rise, we will utilize these in order to get that warning out. In addition, we also rely heavily on webcams. This image below is from the Otter Creek. It's just upstream of the gauge at Center Rutland. And in addition, like I showed earlier with that ice jam photograph, that was a webcam that we have on the Ausable, because not only do we want to know it for river levels, but we want to be able to see as well if ice jams are forming along them also. In addition, we rely heavily on reports from officials, highway department managers that are very familiar with their area, or local emergency responders, police officers, things like that. And in addition, photos and reports from you as well. And so you may be kind of curious, well, what does a river gauge look like? If you're ever driving along the road and you see these little boxes or huts along a river, typically they're green. They are the USGS, or the US Geological Survey's river gauge. And these are reporting what the river flows are on the river. And I am by no means an expert on these at all, other than I know that there are little tubes that intake water, and there's a little float that's in the river that's attached to a tape, or now sort of a digital recording device that records what the flow is, or the height of that bob is in relation to the baseline of the river bottom. If you want more information, there is a link to a publication from the USGS that gets way into the nitty-gritty details on how river gauges work. So check that out if you're interested. And so one of the other things that we need in order to craft sort of the statements that we make in our warnings that we issue has to do with the impacts that occur when these thresholds are met on these rivers. And so we keep track of major river crests and coordinate with town officials, emergency managers, et cetera, about what type of impacts were experienced with these crests. And so you can see this table on the bottom right-hand side. This is for the East Branch of the Ausable. And so based on the different sorts of stages or feet that occur on the Ausable River, there are various different types of impacts that occur. And we delineate these based on action stage, which typically have little to no impacts, but it's something to sort of alert people that, there might be high flows on the river. And we don't issue river flood warnings for action stage. Our trigger threshold for that is minor flooding. And you can see here that minor flooding occurs in Keene, and that water begins to overflow onto various roads. And it's at this point, when there are actual impacts to structures or roads and things like that, that's really the purpose for these river flood warnings. And obviously it goes up from there, where there's moderate flooding or major flooding that can occur as well.
So before we get into a little bit about the National Weather Service products, are there any questions about the River Forecast Center and how we observe rivers? Yes, Terry, I see your question. I'm sorry, could you repeat that?
Okay, going back to Ellicott City, Maryland, I've been to that town. It's really not even the size of a city. It's a very small town, and the town itself is right there by the river, which is very similar to the Ausable River, except for the width. It's a very narrow river, but it's deep. And what I'm wondering is there a table that you would use rather than the greenhouse river gauge type satellite thing like that, is there a regular table you'd use for depth and width of a river versus the amount of precipitation in order to judge whether there's going to be a flat flood or not?
Yeah, so how it sort of works is the depth of the river and the sort of width of the river and all those details that kind of pertain to the characteristics of the river. Those are ingested by the USGS. And then from that, they actually are the ones that create the datum levels, is what we call them, which help us establish those flood stages that you see. So if I go back here, you can see this image actually of this gentleman here, kind of in the middle of the river. That's someone probably from the USGS that is trying to conduct a survey on these river flows. And from that, they use that in all of the surrounding information about, yeah, the city, where the city is, the slope of the river, the slope of the areas around it, to sort of formulate the information that helps them to create those observation points that we see on those hydrographs. So those datum readings that you see, if I go back here, all these little observation points where it says 4.44 feet, etc., that's all based off of the surveys that the USGS has conducted in order to determine at what level the flow is at, and then from there, the impact statements based off of that. So every river, every like Lake Champlain, they all have different datum levels that account for those sort of characteristics of the river. Does that answer your question?
Yes, thank you. That's very, very good.
Okay.
All right, so let's go on to discussing the National Weather Service and how we utilize that river forecast information. Whenever the River Forecast Center forecasts a river to go into flood, we already have predefined sets and points based on the impact statements and the hydrologic surveys that are completed. We have tied to each river gauge, you'll see them in triangles, and the ones with the actual forecast points available all have their circles on top. You can see this one by Middlebury. So highlighted here is the region for Otter Creek. And with that, like you have your predefined sets of points, we can take these different ends and stretch them and shrink them as needed based on the impacts that are occurring. We can also generate for points outside of these river gauges as well. We're not necessarily restricted to those river areas. We can draw polygons and boxes outside of them as well. But you will see, just kind of looking at some of the rivers, now I've zoomed out of just the Otter Creek area and have much of northern New York and Vermont highlighted here. You'll see all kinds of different river gauges across the area, and I also have highlighted where we do not necessarily have some of those river gauges that provide that information. So going back to Terry, your question earlier, one of the other things is we don't necessarily have river gauges or surveys completed at every single small creek or tributary. On a lot of that, we rely on the estimates and reports from observers and officials from what exactly is happening for some of these areas where we don't have observations. So the role of a spotter is key in some of these. Looking at some of the flood products that we have for our area, whenever we issue a flood watch, that is something when we see, like, the River Forecast Center is forecasting several rivers to go into flood, or for a wide area to be potentially impacted by things like flash floods. We issue these watches whenever the conditions are favorable. That's the time to be prepared, to have the action plan in place. The warning is when that is imminent, or when flooding is actually occurring. That's when action needs to be taken. That's when any plans that you have should be set in motion. To help you kind of find some of the information on where you can find some of these tools and informations that we've brought up during this presentation, and to help you assess some of the potential impacts that you might experience in a flood, we'll kind of go over some of where you can find this information. If you were to go to weather.gov/BTV, you would get this map that would show up, as well as a few menus. Under the rivers and lakes, there are a whole assortment of different products that you can view. If you were to look at the river observations based on a map, you can go through and click through several of the different rivers that I've showed before. And if you were to actually click on any of these rivers, you would get to see some of the hydrographs that the River Forecast Center has produced. So you could see some of that same information that we are seeing. There's also a separate map for the forecasts. So you'll see that there are a few less circles and squares here. Not every river has a forecast, and so these will only be those rivers that have a forecast available for them. You can also look at the river forecast. This is a text file that's produced by the River Forecast Center. Contains all of the same information that one would see inside of a hydrograph. You can also take a look at some of the current and past stream flows. I know we have several people that are trout fishers that pay attention to some of the stream flows. You can also see that information by looking at this tab. And for our technical users, you can also even take a look at the Ensemble River Guidance, and that can give you a very quick overview of any areas of potential concern. You could look at a map like this and say, hey, looks like most of Vermont and northern New York is clear of any flooding, but you could see areas of the mid-Atlantic, southern New England, and the Ohio and Tennessee river valleys could be looking at something. Gives you a nice quick glance at potential concerns. And of course, there's also a separate tab that can help you locate the River Forecast Center. They have all of their own maps and graphics as well that you can utilize as well. We're a little outside of spring now, so we won't have any new spring flood outlooks for the next year. But as we start heading into the spring of next year, you can find updates there as well. So like I mentioned, you too can look up a lot of this information about flood impacts and what these different flood stages look like for your local communities. Click your river gauge of interest, and that will open up a page that has the hydrograph, and then you can scroll down, and that has all kinds of information. I can tell you about historic crests and recent crests. You can learn a little bit about how often a river floods based on that information. And you can also see each of the different impacts. And of course, if you do happen to be scanning through this and notice something that is inaccurate or could use some updating, that's information that's useful, and you can contact the webmaster and provide additional details about that. So if you did have a river that is occurring, you can use our point and click map to find warning information. If you were to say click this spot here on the Mississippi River, that would put you to our hazardous weather and our 7-day forecast. You can click here for your flood warning information that opens up the flood texts. That way you can find out what impacts the National Weather Service expects in your local area from any flooding that could be occurring. Are there any questions about National Weather Service products and how you can find them? I know that was rather quick, but again, you do have the PDF available, so that can help you find some of that information, and you can always call operations anytime. We are staffed 24/7 with someone that can help provide you some details on impacts related to any potential floods for rivers that you're interested in. So what can spotters do to help? As I kind of showed earlier, there are several areas where we don't have gauges, where we have observations for what a river stream is like, and we don't necessarily have a lot of information about urban areas or streets. We rely a great deal on spotters, officials, and other people to bring us photos and reports, especially at night. There are instances where, like the Halloween storm, where we might not necessarily know the scope of the event until the sun rises. So this is something that's quite important that a spotter can do to help us out and provide valuable on-the-ground information, but always make sure to never put yourself in danger to report flooding to us. So just to give a quick overview of what we've discussed today, we've talked a bit about how flooding occurs, how it's all about how much water goes into a river and how much is able to go out of that river, and that can scale up to your basins and watersheds. We've talked about flooding versus flash flooding, how gradual contributions can cause water to overflow its banks, and how flash flooding can be from rapid contributions that can cause dangerous water flows in a very short window of time. We've also talked a little bit about some of the North countries, how the combination of climate and terrain leads to things like ice jams and snow melt that can result in flooding across Lake Champlain, or terrains can cause flash flooding, like across the Greens and the Adirondacks. We've discussed a little bit about when it's most common, and we've discussed some of the products that the National Weather Service issues and how you can contribute and help supplement our river gauges. Very brief and quick overview. Many people spend several years earning degrees in this. It's a complicated science, and the reports that we get, the ground truth that spotters provide, is something that's very valuable. Are there any other questions? All right, nothing heard on our end. We're gonna be in the office for just a little bit longer. You can feel free to ask us any questions that you have related to the presentation. I'm gonna go real quick to get to our thank you slide. That way you can see some of our social media information and of course our email addresses. That way you can email us any questions that you might have lingering. One may have said I might have added too many animations there. So here's our contact information. We do have a Skywarn page. We are looking to update that in the near future. We have the unlisted spotter line that you can call us with your reports to, that directly gets to us as opposed to a phone tree. Follow us on social media, and we actively scan social media for reports that are ongoing events, and also seek to answer your questions whenever we see them on social media. With that, I'd like to thank you again for joining us on this webinar.
And please do not hesitate to reach out to us. You can see our email addresses there, and there is the unlisted spotter phone number listed there as well. So if you're, having a shower thought or thinking about this 2 weeks from later and you think of something, don't hesitate to reach out to us. Thank you again.
Hope you have a better understanding of some of our products and how floods occur. Thanks for joining us.